Okay, let's talk about some do's and don'ts of divergences and curls. There are rules you need to follow. It's not really that big of a deal because you kind of just get the feel for it, but definitely don't do something. So, do. You can take the divergence of a vector field. So, in other words, you can take del dot f. And that's because really this is like a dot b. It's a dot product. Don't take the divergence of a scalar. That means don't compute del dot little f, because that's like taking a dot 2. What does that even mean? So, do. You can take the curl of a vector field. So you can take del cross capital F vector, because this is really just a cross product. Don't take the curl of a scalar. Do not compute del cross little f, because what is a cross 2? What does that even mean? Do. You can take the divergence of a gradient. So you can take del dot del f. And actually, it's advisable to take the divergence of a gradient, because this thing, which is del squared f, what this thing looks like is dx dy dz dot dx dy dz. Again, using lazy notation, this should just be this should just be dx squared dy squared dz squared. So in other words, fxx fyy fz z. This is called the Laplacian, and this is so unbelievably important because, for example, if this represents the electric field in electrostatics, which is the first quarter of any EM, of course, then in fact the Laplacian, it actually represents the charge stored by the field. Remember that the divergence of a magnetic field is 0, and that's because there are no magnetic monopoles. However, there are clearly electric monopoles, because you can have protons and electrons. And the Laplacian is the object that allows you to access these two objects. So, what's another do? You can take the gradient of a divergence. So in other words, you can take del of del dot capital F. I'm not going to write what this thing is, and that's because that very, very rarely ever shows up. The actual point of why you would ever need this thing is because often this term is 0. And so this expression simplifies other expressions. Just so you're exposed to some of the language, this is called fixing a gauge. You do not need to know what this means for this course, but at least you've seen it, and it won't be very mysterious later. So, what's another do? You can take the Laplacian of a vector field. And this is called a vector Laplacian. And really what this is just Laplacian applied to each component. You can think of it as the component-wise Laplacian. But don't take the gradient of a vector field, because you'd have to answer, what does A of B mean? What is that? What is this thing? Really what this is actually it's a tensor, but In undergraduate courses, you are not allowed to use these things. It is against the rules. So don't do this. So as long as you follow these rules, that should help keep these objects straight. Just remember that these things correspond to objects like this, and you should be okay. Thanks for watching.